All right, this is going to be part 3 of this video series. I realized that I was using an older version of 3A review when I made the original first 2 parts. So I went through and found the ones that had incorrect information on them, and I'm redoing them in this video. So the first one is number 2. It should have had a little bit of a different setup. It was negative 2x squared minus 16x minus 24. We'll pull out a negative 2 to kind of see what this is going to look like if we were trying to factor it. So that's x squared plus 8x plus 12. We can also find, so this is going to open down because of the negative in front. Its vertex will be negative b over 2a, which would be 16 over 2 times negative 2, which is 16 over negative 4 or negative 4. And then we have to find the y value of that, so plug that into the equation. So that is 16 times negative 2 would be negative 32. This is positive 64 minus 24, so that's going to be 32 minus 24, so I'm getting 8 for that. So then to find the x-intercepts, we need to set this equal to 0 and factor. That would be plus 6 and plus 2. So that's going to be an x of negative 2 and an x of negative 6. So our x-intercepts are negative 2 comma 0, negative 6 comma 0. And the y-intercept is going to be 0, negative 24, because it's the constant term if you plug in 0 for all the x's. And then the axis of symmetry is x equals negative 4. So we're going to put all that together and graph that. So if we count by, let's say we count by 2's, then this would be negative 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So my y-intercept's down here at negative 24. My x-intercepts are at negative 2, which would actually be right here if we're counting by 2's. So let me erase that real quick. So negative 2, and at negative 6, which would be 2, 4, 6, so negative 6. And then the vertex is negative 4 and then down 8, so, no, excuse me, up 8. So that would be 2, 4, 6, 8. So we get this parabola going like this. And it's upside down. Okay, so for the next one, we're supposed to write it in vertex form. The difference was that the sign was changed on the middle term in the updated version of the review. So we're going to pull out a negative 4 again, but that's going to make this x squared minus 4x, and then blank. Then we'll have our minus 10 and our counter blank. We take half of the middle term, putting it in vertex form, and that would be negative 2 squared, so that's going to be a positive 4. But because we are doing really negative 4 times 4, that's negative 16, so we want to counter that and put in a plus 16. So that part didn't change. It was just this factoring right here. So this is f of x equals negative 4 parentheses x minus 2 squared, because that's a negative 2, and then plus 6. So my vertex is actually 2 comma 6. So that's that part. For the next one, there was a 6 as a multiple on the x squared on the first function. That was an update to the original. So we need to do f of g and g of f here again. So f of x is my red function, g of x is my blue function. So f of g of x would be, in this case, 6 blank squared minus 5. And in the blank, we put the 4x plus 7. So we need to do 6 times 4x plus 7 times 4x plus 7, because it's being squared, and minus 5. we'll FOIL this out again. I believe this was 16x squared plus 28 would be plus 56x plus 49 minus 5. And because of this, now we have to make everything multiplied by 6. So 16 times 6 is 96x squared. 6 times 56 is 336 x, and then 49 times 6 is 294, and then we need to subtract the 5 from that last part, so it's 289. So this one would be 96x squared plus 336x plus 289. So that's f of g of x. For the other way, we're doing g of f of x. And we would be doing 4 blank plus 7. And then in that blank, we're putting the 6x squared minus 5. When we distribute this, that is 24x squared minus 20 plus 7, or 24x squared minus 13. Okay, on the original video, my number 9 should have been the number 8, I believe, on the updated review. So there was an extra graph in there. This is the one that should have been number 9. So we're trying to sketch f of x equals this polynomial, and we want to know when is f of x above or below 0. So the first step is to factor that by pulling out the x squared in the first pair and the minus 9 in the second pair, which makes that a negative 3. That equals x minus 3 and then x squared minus 9, which is x minus 3 times x minus 3 times x plus 3, because this one factors into those two, or x minus 3 squared and then x plus 3. So my zeros are negative 3 and positive 3. The multiplicity, remember that's how we did this, or you can do this by the sign chart if you want, but for negative 3 that occurred once because it has a exponent of 1 on that factor. The positive 3 came from this factor, which occurred twice. And the behavior, remember, is if it's a 1 or an odd number, you're going to cross through it. And if it's 1, it's crossing straight through it. If it's 3, 5, 7, something like that, it's crossing kind of like x cubed at a little squiggle. If it's an even multiplicity, then it's going to do a bounce. And then the end behavior, that's related to the highest power if you're in standard form here. So that's a degree of 3, which is odd. And the leading coefficient is positive. So that is down on the left and up on the right. So we should now have enough information to graph this and get a rough sketch. So we plot our x-intercepts of negative 3 and positive 3. And we know we are down on the left and up on the rightmost one. At negative 3, we're supposed to cross straight through. So we go up. At positive 3, we're supposed to bounce, which makes sense because we go down, but then we bounce right back up towards our end behavior. So my f of x is greater than 0 from negative 3 to positive 3, and from 3 to infinity, because I'm above the x-axis on both of those regions. And my f of x is less than 0 from negative infinity to negative 3. And those are parentheses, by the way. Okay, and then the last one that needed a correction was number 18. In the original version of the review, we had an x squared on top. So if we're doing vertical asymptotes, horizontal asymptote, or oblique, then we need to look at this version. For the bottom, you still factor it. And it factors into x minus 2 and x minus 3, so the vertical asymptotes are still x equals 2 and x equals 3. But when you go to do the long division to test if it's horizontal or oblique, this does not go into this at all because this is a bigger power. So that means it's horizontal since you get no x's on top when you divide. So it's y equals 0. And this would be none. And that is the correct versions of all of those in the new updated version of the review. All right, thank you.